Hello, welcome back to our lecture series on carboxylic acids. In the previous video, we talked about how we can name carboxylic acids. But let's review how we can make a carboxylic acid. Once we know how to make carboxylic acids, there's a lot of reactions we can do to react carboxylic acids and convert them into other things, right? So let's go back over some reactions that we learned about. So if we can take a aromatic ring here, and has a benzylic position. In terms of having a CH carbon here at the benzylic position of our aromatic ring, we can then react that with what? KMNO4. And if we do this reaction here, we're going to end up getting what? We get our carboxylic acid, right? So we take KMNO4 usually with acid. We need acid in there as well, but we're more concerned about just this reagent here, right? This is our important reagent. We can oxidize this benzylic position to a carboxylic acid. Now, what's great about this reaction is if I take any group out here, as long as I have one CH here, one CH at that benzylic position, I can oxidize that to that carboxylic acid, right? It will always oxidize it. Again, it doesn't matter as long as I have one CH here. So I can go as long out here as I want. We'll oxidize it, KMNO4. We'll get that carboxylic acid, right? Notice how we always have a CH here at this benzylic position. That benzylic position is going to be the carbon directly attached to our aromatic ring, okay? Now, what if I do something like this? Notice here, now I have just 3 carbon groups attached to this benzylic position, right? There's no place to have it, there's no CH bond. So if I try to make KMNO4 with this, what do you think happens? Since I don't have a CH bond here at the benzylic position, I get no reaction. Okay? So this reaction works great as long as you have at least one CH at that benzylic position. And then we can convert our alkyl group to a carboxylic acid using KMNO4 under acidic conditions. Okay, so that's one way we can make a carboxylic acid with involving an aromatic ring, right? There's one other way we can make a carboxylic acid with an aromatic ring. This is kind of a nice way to work with. So I can take my I can take my aromatic ring. I can react it with Br2, FeBr3. And we know if we take Br2 with FeBr3, that's going to do what? It's going to brominate our ring. All right. And now if I take my bromine on here, I can treat it with what? Mg. Why do I want to treat it with Mg? What's going to happen when I treat my bromine with Mg? We're going to generate our Grignard reagent, right? Okay. I can make my Grignard reagent. And what's nice about this is once I have a Grignard reagent, I can do a reaction now. I can react this with CO2. And the second step is H3O+. And what this is going to do is that our Grignard reagent, which is very nucleophilic, it's going to attack this carbonyl, CO2, and we can generate the carboxylate anion, which is then protonated by H3O+ to generate what? That generates our carboxylic acid, right? This is another way we can make that carboxylic acid there, okay? And so we can take our ring and go into a carboxylic acid here. Now, it doesn't necessarily have to be on aromatic ring. Anytime we can make a Grignard reagent, we could do this reaction and turn it into a carboxylic acid. It's really nice with this way because we know how to brominate our aromatic ring here. So if I have like this with MgBr, I can do the same reaction. CO2, and the second step is H3O+. And we can generate our carboxylic acid. Now, what's nice about this too, not only are we adding carboxylic acid on here, but we're actually adding one carbon unit, right? By adding this CO2 here, you're adding one more carbon to our chain. So that's nice. So this is another way we can do it. We can take a Grignard reagent, right? A Grignard reagent, react with CO2, H3O+ to generate our carboxylic acid. Okay, so we're up to 2 ways so far how we can make a carboxylic acid. So let's look at some other ways. We can look at some more of the straight oxidation reactions with what? What about taking an alkyne? Let's look at a terminal alkyne. I can take a terminal alkyne and I can oxidative cleave with this, right? I can do O3. So O3 with my alkyne is going to do what? We're going to get that cleavage of the alkyne, and we're actually going to generate a carboxylic acid plus CO2. So that's pretty nice that I can take the terminal alkyne, I can do oxidative cleavage of that, kick off this carbon group, which leaves as CO2, and we generate a carboxylic acid. Now, what happens if I take this and now I put in a, now this way, O3. Now this is a terminal one, it's in the middle. We're gonna do the same thing, we're gonna cleave it. In this case here, we're gonna get 2 carboxylic acids. Right? As we cleave this, we're gonna get cleavage and we'll get the 2 fragments. Both are gonna be carboxylic acids. Okay? So this is the way we can do it with O3, ozonolysis, oxidative cleavage, right? Other ways you can do it is, the last way we can think about doing this is with our alcohols, right? Now, we can take this type of alcohol, which is going to be, what type of alcohol is it? It's going to be a primary alcohol, right? Primary alcohol. And we can react it with Na2, CrO, Cr2O7, the chromium reagents, right? And this is going to be with H2SO4 and 1. And we can oxidize it. Primary alcohol can be converted into a carboxylic acid. We can oxidize. So that's another way we can make a carboxylic acid, right? We can take a primary alcohol, react it with our chromium reagents to generate, oxidize it to a carboxylic acid. Now this one only works if we have a primary. If we have a secondary, looking like this, and I try the same reaction, what do you think is going to happen? Now we have a primary one. We have these 2 groups here. We're not going to lose these groups. These groups are going to stay. So we end up what? We actually oxidize it to this group here. We call it, what group is this? It's going to be our ketone, right? So that's another way we can, so this way here we have a secondary, we get a ketone, right? Has to be a primary, okay? And so we can see here, we've talked about so many ways. 1 with our Grignard, 2 with O3, this is going to be 3, and then 4 was the K-vinyl 4 at a benzoic position, right? So these are our ways that we can make a carboxylic acid. So make sure we review these reactions, make sure we can use them, right? Now we can go from some other functional group to a carboxylic acid. In the future videos, we'll talk about what we can do once we have a carboxylic acid. What are the reactions we can do? And just like we saw with aldehydes and ketones, we're going to see a lot of the same mechanisms over and over again. Very repetitive mechanisms, right? Because what? We have a carbonyl. We already know this carbonyl is going to be electrophilic. But we'll have to work with this OH group a little bit more because, again, OH group isn't really a good leaving, right? We'll talk about that, what we can do with that, okay? So there's our ways to review our reactions, and we'll look at some new reactions here in the future videos.